This is Unit 12, Lesson 1, Video number 3. Now, we're not always going to be provided with a unit circle. In fact, on your AP exam, you will not be provided with a blank unit circle or a completed unit circle. So, as we go through this lesson, I'm going to advise that we create the first quadrant with these common angles of 30, 45, and 60. Remember, one shortcut to this is 1, 2, 3, 1, 2, 3. The denominator for both sine and cosine will contain a 2. And then I'm going to take the square root of each numerator. Square root of 1 is just 1. Square root of 2's and square root of 3's are irrational. Now, in video number 1, we talked about how to determine the tangent of these common angles of 30 degrees, 45, and 60. And you can see that we did that earlier. So at 30 degrees, I'm going to write radical 3 over 3. So this is going to be the tangent is radical 3 over 3. I'm just going to circle it so it stands out. Tangent of 1 and tangent of radical 3. And we'll use these as reference angles when we complete the following 5 examples. Let's start with All-Star Trig class. All-Star Trig class. Where are signs positive? Signs are positive in quadrants 1 and 2. So in quadrant 1 and 2, I'm looking for a sine value of 1/2. CBS, cosine before sine, tells me I'm looking at a reference angle of 30 degrees or pi over 6. So pi over 6, that's in quadrant 1. Now a reference angle of 30 degrees, also known as pi over 6 in quadrant 2, would be 5 pi over 6. Now how does that relate to example 7b? Example 7b, we have something new that we're introducing. This time we have a number in front of the x. Sometimes this will be a theta. We'll achieve the answer in the exact same way. So how are we going to do this? We're going to do 3 revolutions. So I am going to bring, just for this particular example, I am going to bring this back in so that we can have a visual of what this looks like. So 3 times. The very first time, I'm going to set 3x equal to, and I want to ask myself, where is a sign equal to positive 1/2? Well, I already did that work. It's at 1 pi over 6, and it also can be found at 5 pi over 6. Now notice it's 3x equals this amount. 3x equals this amount. We didn't have to do that over here because there's a hidden 1, and dividing by 1 doesn't do anything. So in the first revolution, and I'm going to go 3 revolutions for this problem, in the first revolution, I need to isolate the x. I could divide by 3, but even easier would be to multiply by 1/3. So x equals 1 pi over 18. Again, divide by 3, or even easier, multiply by 1/3. The second answer is 5 pi over 18. Let's move on to our second revolution. And the second revolution, I'm going to grab my unit circle. I want to land on these exact 2 spots. So 1 time around would be 12 pi over 6. How do we achieve that? 1 over 6, 2, 6, 3, 6, 4, 6, all the way to 12 over 6. Landing here would be 13 pi over 6, 14, 15, 16, and 17. 17 pi over 6. Now before I isolate, let's do one more round. We need to do 3 rotations. So every time we go around, we're adding 12. So notice that when I land here, I add 12, I'm up to 13. I add 12, I'm up to 17. So let's be lazy. Add 12, I'm up to 25 pi over 6. And add 12, I'm up to 29 pi over 6. To isolate the x, again, we could divide by 3, but even simpler will be to multiply by 1/3. So one answer is 13 pi over 18, 17 pi over 18, 25 pi over 18, 29 pi over 18. Now I can demonstrate really quickly how this does work. Remember, with any equation, we should be able to prove the left side equals the right side by plugging in the answers. Let's try one of these. Making sure, first of all, that we are in radians. I'm going to type in the sign. We have a 3, and I'm going to multiply it by 1 pi divided by 18. And I should receive an answer of 1/2. We do. Let's try another random one. Sine 3. This time, let's try 25 pi divided by 18. And we can see we still get an answer of 1/2.